Hidden Magnetic Portals Around Earth, presented by Science at NASA. A favorite theme of science fiction is the portal.
Science fiction? Looks like science fiction is a favorite theme of NASA.
An extraordinary opening in space or time.
Extraordinary only because you made those holes with your rockets.
Rise, rise. Do you hear a fever? Do I smash the mirror?
That connects travelers to distant realms. A good portal is a shortcut, a guide, a door into the unknown.
A shortcut, a door, a guide. Yeah, holes in the glass sky would be a shortcut to inner space.
If only they actually existed.
But they do exist, thanks to you.
It turns out that they do.
See?
Sort of. And a NASA-funded researcher at the University of Iowa has figured out how to find them. We call them X-points.
X-points.
Or electron diffusion regions, explains plasma physicist Jack Scudder of the University of Iowa.
Jack Scudder for the win.
They're places where the magnetic field of Earth connects to the magnetic field of the Sun.
Well, yeah, you call it the magnetosphere. I call it the magnetosphere because it's magic. It makes the holes in the glass sky invisible,
creating an uninterrupted path leading from our own planet to the Sun's atmosphere 93 million miles away.
93 million miles away.
Observations by NASA's Themis spacecraft and Europe's cluster probes suggest that these magnetic portals open and close dozens of times each day.
Well, yeah, they do open and close daily. You ever hear of the Faraday effect? Where magnetic flux penetrates a once blocked polarized light medium, glass.
They're typically located a few tens of thousands of kilometers from Earth.
Oh, no, not the gigantic imaginary octopus, no.
Where the geomagnetic field meets the onrushing solar wind.
They meet at the glass sky, liar. The Libyan desert glass, which are pieces of glass sky that fell down in the Libyan desert long ago, have traces of magnetic iron little spherules inside. The Libyan desert glass also has a birefringence to it, which creates the polarized light.
Most portals are small and short-lived.
They're only short-lived because the magnetic flux is not always perpendicular to the holes, as the sun revolves around the inside of the Earth on a daily basis.
Others are yawning, vast, and sustained.
Vast, sustained, yes, some are because you've made bigger holes in the glass sky, such as Operation Fishbowl. Remember that one?
Energetic particles can flow through the openings, heating Earth's upper atmosphere, sparking geomagnetic storms, and igniting bright polar auroras.
Look at all those atmospheric holes found in the polar region, thanks to L.A. Frank.
NASA is planning a mission called MMS, short for Magnetospheric Multiscale Mission, due to launch in 2014 to study the phenomenon.
So you're going to punch more holes in the glass sky to study more holes. So you have a higher probability rate. Genius, Einstein.
Bristling with energetic particle detectors and magnetic sensors, The 4 spacecraft of MMS will spread out in Earth's magnetosphere and surround the portals to observe how they work.
Only 4? How about more? The more holes you punch, the more holes you'll be able to see.
Magnetic portals are invisible.
Invisible. The glass sky and the holes are invisible. It's shrouded in a magnetic field that makes them invisible. Job 38 verse 30 says, the sky is hid as with a stone. In that case, opaque, but in the real sense, it's transparent.
Unstable and elusive. They open and close without warning.
Open, close without warning. Duh.
And there are no signposts to guide us in, notes Scudder. Actually, there are signposts, and Scudder has found them. Portals form via the process of magnetic reconnection. Mingling lines of magnetic force from the Sun and Earth crisscross and join to create the openings. X-points are where the crisscross takes place. The sudden joining of magnetic fields can propel jets of charged particles from the X-point, creating an electron diffusion region.
Scudder, you sly devil, X marks the spot. You figured out that the magnetism from the Earth meets the magnetism from the Sun at the glass sky opening.
To learn how to pinpoint these events,
There's that stupid imaginary octopus again.
Scudder looked at data from a space probe that orbited Earth more than 10 years ago.
10 years ago, there were less holes back then because they didn't punch as many, obviously.
In the late 1990s, NASA's Polar spacecraft spent years in Earth's magnetosphere, explains Scudder, and it encountered many X-points during its mission.
Oh, but there's still plenty.
Because Polar carried sensors similar to those of MMS, Scudder decided to see how an X-point looked to Polar. Using Polar data, we have found 5 simple combinations of magnetic field and energetic particle measurements that tell us when we've come across an X-point or an electron diffusion region.
Electron diffusion region for the win.
A single spacecraft, properly instrumented, can make these measurements.
Well, look at that. A magnetic field tracing the contour of the glass sky. That's great.
This means that a single member of the MMS constellation, using the diagnostics, can find a portal and alert other members of the constellation.
Other members. Hey, the more holes, the better. The easier to find the holes. Punch more holes, find more holes. Makes sense to me.
Mission planners long thought that MMS might have to spend a year or so learning to find portals before it could study them. Scudder's work shortcuts the process, allowing MMS to get to work without delay. It's a shortcut worthy of the best portals of fiction.
Fiction, there's that word again. NASA, creators of fiction.
Only this time, the portals are real.
Real? Yes, the holes that you punched in the glass sky are definitely real, you asshole.